My name is Christian Abouin. The company is Hexagon NovAtel, and I'm going to talk about GNSS and AI solutions for autonomous navigation. Well, thank you very much. First and foremost, I'd like to tell you more about Hexagon. I'm not sure that this is a known name. It's a larger group originating in Sweden. 25,000 employees, 6 billion revenues, 6 divisions. I'm part of a division dedicated to autonomy and positioning. There are different subgroups. One group is also working with defense. There's a need for GPS solutions for the army. There's also a group for the aerospace industry. Airbus is one of our customers. There's also a segment for the automotive industry because they also need a GPS solution for cars that become more and more autonomous. And my segment is dedicated to solutions for agriculture. Within that segment, we have different solutions that make robots more autonomous. And before we start, I'd like to thank you for deciding to be here. And I'd like to make the FIRA slogan mine. The revolution, the agricultural revolution is at our doors, and it starts here. Used to be the FIRA motto. And so we're here to share our perspectives on the future of agriculture. So what we do are different solutions, GNSS, but also AI, and again, this with a view of making robots more autonomous. Christian, you need to navigate your slideshow with the remote control. And technically, yes, we need to have your slides in full screen. There we go. Yeah, the remote control should help you navigate the different slides. Oh, thank you. So, you know that the agriculture industry is facing a number of challenges. We need to feed a growing population and also find resources in order to feed the world. In this particular framework, robots are going to play a central role, and they need 3 technical prerequisites. First is accurate positioning. Second prerequisite is visual recognition of the robot's environment, and then automatic guiding. I'm going to talk about those 3 dimensions, those 3 prerequisites, and there will be no tests, so I won't be asking questions at the end of my presentation, so you can relax and listen to my talk. Why is it that positioning is key to autonomy? Well, it all starts with an accurate position. It has to be centimeter precise in order to reduce errors, in order to avoid any part of a plot to be missed, and to make for an accurate work. It is very demanding to work in an agricultural setting. It may very well happen that a part of a plot is covered by trees and you lose signal, or there may be plots that are not covered by any signal altogether. This is where INS span is a technology of interest, where you combine a GNSS sensor plus an inertia sensor, which is going to correct the signal, and that way we're going to reduce the RTK losses, and the signal will be smoother and also more long-lasting, if you will. So this will help in the identification of loopholes in the map, and again, the map will be accurate and reliable even without signal. Another interesting prerequisite, visual recognition. I talked about the first prerequisites, positioning. You need to know exactly where the robot is located, but the robot needs to know what's happening around it. To do that, we use different technologies and different sensors, LIDAR, radar, ultrasound, but also vision. And vision is going to be supported by AI. AI is going to help the camera to classify objects, recognize human supports, for example, and make decisions based on what you see. So it's when I say we, it's not necessarily a human person, a human being, but it's more AI. It's again the software is going to see this information, and ask for confirmation if needed by the operator. Well, I assume that some of you have already seen autonomous robots, and well, that's the right place to do that. You just have to give a look outside the window. So let's assume that one of the robots, one of the sensors stops working, and the robot just decides to come here in the room. Well, we have multiple systems with an overlap using AI, vision, and those robots are able to identify 3 spaces, but they're also able to classify different objects and adapt their behavior accordingly. For example, we talked about a robot losing control. We can very well envisage that there are children in the field, and so the decision is made to stop the robot immediately, and the robot is able to do that by itself. Also, there may be a hay ball on the itinerary, shouldn't have been there, but the robot may make a decision to go around that obstacle. Our solutions are designed in order to integrate perfectly. I'm sorry, says the speaker. A slight computer glitch. Right, so our solutions are designed in order to fit in a system, and we are compliant with a number of norms and standards, notably ISO 18497, which describes the safety requirements for automated machines. So if you want to be compliant in full or only for some of your parts, all technologies are a reliable basis. Our components can be integrated in your solution in order to meet the stringent requirements of standards, all the while making sure that operation is at the highest standard of quality. When you choose our solutions, you use advanced solutions, but also this is an easy way for you to get your automatized or semi-automatized system certified. I'm sorry, the guy is reading a text and I don't have the text. Now, once everything is designed, you need to transform those GSM data and transform those in accurate movements. Now, how can we do that? We have a platform which integrates GNSS maps plus an RTK model. And thanks to that, there's a merging of visual data and GNSS data, and that way we create independent autonomous trajectories. The trajectories are then sent to the robot, and the robot is then working in a very smooth fashion independently. It reduces the operation cost, improves accuracy, improves productivity. By means of illustration, let's assume that you have a plot with different slopes, with different obstacles, and thanks to automatic guidance or guiding, the robot is navigating those while avoiding errors. So we've just seen three main prerequisites to a robust autonomy. So GNSS plus INS span, robust, reliable. Second prerequisite, visual perception for smarter robots, and automatic guidance or guiding to transform the two first prerequisites in a solution. We want to have high performance solutions that are so accessible because we want to have more farmers use this technology. Thanks to those technologies, the farmers will be able to tackle tomorrow's challenges. My name is Christian Rabois. We have a booth number 27. You may want to come and talk with me if you'd like to become a client or if you have questions. Thank you for your time and attention. Well, before they see you on your stand, maybe they have questions that they'd like to ask now. You know, teachers are usually very curious people, and that's great. So another question. Yes, I'm a teacher in a secondary school dedicated to agricultural techniques. You're talking about robots and positioning. Today, when we talk about robotics, we can talk about flying robots, for example, drones that are more and more used for different agricultural tasks, bearing weight, for example. Some Asian companies are leader on this market. Could you envisage on the short, medium, or long term a European robot? Yes, it would be called Airbus, right? Yes, those solutions are, of course, interesting. Thank you for your question. But it requires miniaturization. It requires the different components to be miniatures. You talked about Asian players, and you're right. On the medium term, we will potentially sell our software or AI, but we do not want to position ourselves on hardware. We just want our software to be compatible with any type of application, but we do not want to become an expert in that type of hardware. It's just not in our pipeline. Good afternoon, Bernard Duval. I have a question on a previous presentation. We heard that sometimes GPS data is not enough, especially if the lines are not straight. Are you merging video data and GPS data to adapt to the road? Well, that's an excellent question. Thank you for that. This is indeed data merging. So we have the theoretical route or itinerary, and then we try to compare the theory with real theory. And so we can rectify as we go and adjust. Now, we could also use that to update the map accordingly. So this is feasible. Well, I have also another question related to that one. So the robot has this itinerary of its route. Can AI automatically correct the route, or again, do you need an operator correcting? Yes, the operator may be needed. What we want, obviously, is an autonomous robot. I have a robot at home hoovering the floor, and I do not want to mop the floor afterwards. So I do not want to be there when the robot is hoovering the floor. And same applies to our farmers, I suppose. They do not want to, I suppose they do not want to have someone by the side of the robot. Now, of course, you can very well envisage that maybe because of a gust of wind, there are branches in the plot, on the plot. And so you need to have real-time reaction, and AI is going to react to that. So you have an alarm on the software interface. The farmer is informed that there's a branch or a larger tree trunk, and the farmer is going to react accordingly. Thank you. Can you please introduce yourself? My name is Paulo Gay.
What about the use of artificial intelligence in this kind of application? I mean, that could be critical with respect, for example, to the AI Act of the European Commission.
Oh, that is true.
I don't know if I should answer in French or... Ok. Alors, j'ai eu les régies qui me disent de parler en français, du coup. Parfait.
Okay, so I didn't talk about this regulation simply because it is not yet fully integrated. However, currently we have development kits. So those are not things that are going to be marketed next year, but I'm sure that by 2026 our teams will integrate all regulations. And of course, we are very cautious to respect this regulation. Yes, again, around regulatory affairs, AI is a key word, but when we think about technology and changes in technology, do you work with the different players, the different regulatory players? In France, for example, we have a certification body named AFNOR. Do they help you evolve your products? Because I suppose it's in the interest of everybody that you are at the cutting edge. Do you already have partnerships with those certification bodies, or do you wait for the regulation to be published to adapt, or do you have a more proactive approach? Well, thank you for that question. As I said before, our company has a very global footprint. So we first respect international standards, ISO standards, for example, and AFNOR, the French body, also respects ISO standards. We have a very global vision, and we try to offer a solution for all clients, irrespective of where they are on the globe. There are developments in Japan and in Australia as well from our groups. So we try to really answer international customers' demands. A last question before we wrap up. Of course, go ahead, Bernard. So at the end of the day, follow up to a previous question. Let's assume that I purchase a robot and then I want to install your software. Is it compatible, interchangeable? Well, very good question, Bernard. Well, I do invite you to buy a robot here. Maybe you're going to have a good price if you purchase here. However, our product, our software, is not designed to be retrofitted. It has to be integrated in the different software layers in order to be cohesive. So maybe one day you'll go to your dealer and maybe, 10 years down the line, we'll have a retrofit kit. But currently, that is not the case. We need to respect a number of standards. It was underlined. We need to calibrate the different the different cameras. So we are mostly selling that to OEMs and manufacturers. So you need to be integrated in the supply chain of a large manufacturer. So if we talk about your clients, you are mostly talking with OEMs and larger manufacturers, right? Well, of course, we take into consideration the feedback of customers. We need to collect intelligence and feedback from our customers because we really need to inform our R&D based on what our clients need. However, we do talk mainly with the larger players, large and small, but those are not our only clients. Thank you.